In this video, we are going to learn about different ways to set up proportions. Let's begin. Let's review what a proportion is. It's an equation where two blanks are set equal to each other. It is two ratios are set equal to each other. Now, proportions are a helpful tool that can be used to answer many different math problems. They can also be set up in many different ways. So you probably already know how to set up a proportion, but we are going to show you that there are lots of different ways to set up proportions. And different people will prefer different methods, and we just want to show you that there's more than one way to do it, and you can pick whichever method that you think works best for you. There's an example up top of a couple different proportions that will work for this word problem. So let's read the word problem. We've got a recipe for tropical punch states that you can use 2 parts mango juice for every 3 parts of guava juice. So we're going to use 2 parts mango juice for 3 parts of guava juice. If you use 12 cups of mango juice, how many cups of guava juice should be used? So let's take a look. This is one way of doing it. We could put mangoes on top and guava on bottom. So we know that 2 parts mango juice for 3 cups of guava juice, 2 parts mango juice, 3 parts guava juice. So that's the ratio, that's the original ratio. And it says we're going to use 12 cups of mango juice, so how many cups of guava juice should be used? And that's why that variable is down there. We can also reverse it. We can put the guava on top, so 3 parts guava to 2 parts mango, and that's fine to put the guava on top and mango on bottom. Some people do that for some reason, and that's okay. So notice the 12 is down here because the 12 goes along with the mango. So if we have 12 cups of mango, how much guava? How much guava? And that goes with guava up there. We also have it set up this way. You have 2 parts mango juice and 3 parts guava juice. So mango's on the left, guava's on the right. So if you use 12 parts mango, again, on the left along with the mango, how much guava? On the right with the guava. Or you can reverse it, 3 parts guava, 2 parts mango. So if we are doing 12 cups of mango, that goes on the right side with the mango. And then how much guava? That goes on the left side with the guava. You can also set it up this way, which would seem kind of weird, but if you have if you're using 12 cups of mango, how much cups of guava? And then we know that the original ratio was 2 parts mango and 3 parts guava. You'll still get the right answer if you set it up this way. This one is the same way, except it's reverse. Guava's on top, mango's on bottom. So the original ratio is 3 guava to 2 mango. Notice the 2 mango numbers are together, 12 and 2, 12 and 2. Over here, we're setting them up vertically. 12 mango to how much guava? And we know that the original ratio was 2 mango to 3 guava. And notice again, the mango numbers are together, 12 and 2. And over here we have guava to mango. So how much guava if you're going to use 12 mango? Well, the original ratio was 3 guava to 2 mango. So lots of different ways to set this up. I think these last 4 are kind of a weird way to set them up, but you're still going to get the right answer. Anyways, let's go ahead and look at some examples and see if we can fill out some of these proportions. So example 1 says the ratio of raisins to peanuts in Grant's granola recipe is 3 to 5. So it looks like the ratio is 3 raisins to 5 peanuts, right? So it's going to be 3 raisins, 3R to 5 peanuts. I'm going to say 5P for peanuts. If Grant is using 15 cups of raisins to make a new batch of granola bars, how many cups of peanuts will he need? So he's going to use 15 cups of raisins. So we have 3 raisins, 5 peanuts, and 15 raisins. How many cups of X number of peanuts? I'm going to put a question mark. How many cups of peanuts is he going to need? So it says 4 different students started setting up the proportion. Can you finish setting it up? So this is 3 and 5. 3 refers to the raisins. 5 refers to the peanuts. And it's saying that he uses 15 raisins. So would that go on top or on bottom? Well, it should go on top because you put the raisins on top. So 15 raisins. How many peanuts? Let's use the X right there. That's going to be our variable. So X peanuts. Someone started setting it up this way. They did 3 raisins on the left side and 5 peanuts. They put the peanuts on the right side. So if you're going to do, if we know that Grant used 15 raisins, where does that go? Well, it goes on the raisin side, which is on the left side, so 15 raisins. So how many peanuts? That's where our X goes. Someone set it up this way, 5 and 3. So 5 refers to the peanuts, 3 refers to the raisins. So 15 raisins would go on the right side because that's where the raisin side is, which means the missing number of peanuts is going to be on the left side. And over here we have 5 and 3. 5 refers to the peanuts, right? 5 peanuts. 3 refers to raisins, so 15 raisins goes on the bottom because I decided to put raisins on the bottom right there. And peanuts, that goes up there. And that's going to be our unknown number of peanuts. And by the way, if you solved this, you would have gotten 25 cups of peanuts. Not important. Well, more important later, but or more important, but let's just move on, since I assume you already know how to do this. Example number 2. We've got, in order to make dark green paint, Carmelita mixes 3 parts yellow paint to 7 parts blue paint. So far, she has poured 13 ounces of yellow paint in a bowl. How many ounces of blue paint will she need to add to the bowl? So it looks like she is doing 3 parts yellow and 7 parts blue. Ooh, I should have a blue highlighter. That would be cool. So far she has 13 ounces of yellow. How many ounces of blue? So that's the thing that we don't know. So we got to start this from scratch. She wants to make dark green paint. Our ratio is 3 parts yellow to 7 parts blue. So 13 ounces of yellow. Where does the 13 go? It goes with the yellow on top, which means we don't know how many ounces of blue. And that's where it goes down here along with the blue. So if we're going to use 7 blue, then how much blue do we need if we have 13 yellow? Let's set it up another way. I could do 3 yellow for every 7 blue. So if we're doing it this way, 3 yellow for 7 blue, 13 yellow, the other thing we know, that goes down there. And the unknown amount of blue goes right there. I can also do, instead of yellow to blue, I can do blue to yellow. So I can say Carmelita uses 7 blue for every 3 yellows. So 15 yellows, that goes down here. 15 yellows for how many blues? Or I can do it again, 7 blues to 3 yellows. So if I'm going to use 15 yellows, that would go over here. How many blues? That goes right over there. And if I solve this proportion, I will get any of these proportions. I should get the same answer for x. Question 3, example 3, it says that 32 students signed up to try out for the mountain biking club. The ratio of boys to girls in the club is 5 to 3. How many girls are in the club? Ooh, this is tricky. This is one of those dreaded ratio to all questions. So we have the ratio of boys to girls, which is 5 to 3. So it's 5 boys for every 3 girls, and it says we have 32 students total, 32 all. And when we run into this kind of question, we need to know the ratio number of all students. So it's asking us to find how many girls are in the club. I need the ratio number of girls, which is 3. So if the ratio of boys to girls is 5 to 3, the ratio of girls to all would be 3 to 8. How do I get 8? Well, you add 5 and 3. If there is the ratio is 5 to 3, then you add 5 and 3, and that gets you the ratio of all students. So the ratio of girls to all would be 3 to 8. The ratio of boys to all would be 5 to 8, but we don't need to know that part. What is 32 then? Well, 32 is the actual number of students. Do we know the actual number of boys? No, we have no idea. Do we know the actual number of girls? No. That's what we're trying to figure out. But we do know that we do know the actual number of students, and we know the ratio of all students, which would be 8. So let's take a look at how Ed set it up. 5 and 3 and 32. 5 refers to the boys, right? And 3 refers to the girls, and 32 refers to all. So what he has right here is like 5 boys to 32 all. That can't be right. Ed did not do it correctly. That's like how Faith did it. 3 refers to the ratio number of girls. 8 refers to the all, ratio all. And 32 also refers to all. And X refers to how many girls, right? That's what we're trying to figure out. So the ratio of girls to all is 3 to 8, and that's correct. And we have X to 32. How many girls if the actual number is 32? Faith did it correctly. Good job, Faith. Da-ding. Let's take a look at Gary. Gary, 5 boys and 3 girls, and 32 is the all, so that's not correct. It's like set up a ratio of 3 girls to 32 all, and that's not the ratio number. The ratio of girls to all would be 3 to 8, not 30 to 32, because 32 is the actual number of all. So that wouldn't work. And also, if you look across 5 to something, that would get you the ratio of boys. So that's just not right either. And we've got Helen. 3 refers to the girls. 32 is the all number. And then 8 refers to the all number as well. So the ratio of girls to all is 3 to 8, right? And then there are actually 32 students, and that is on the wrong side. That should go on this side. So the X should be over here, and the 32 should be on that side. So this is wrong. So the only person who did this correctly is Helen. Or sorry, not Helen, is Faith. Faith is the only one who did it correctly. Good job, Faith. Did they set up the proportion correctly? If not, why not? Lots of ways to explain this. Ratio of girls to all is 3 to 8. And they don't have the ratio number. Faith did it correctly, so Faith, check mark. We can also even just write correct. Gary, lots of ways. They did not have the ratio of all. Ratio, again, same as before, ratio of girls to all is 3 to 8. And they do not have the 8. And finally, Helen, they do have 3 to 8, but the 32 is on the wrong side. I mean, you could also say the 3 is on the wrong side, but I would say the ratio number of all students and the actual number of all students need to be on the same side. All needs to be on the same side. And when we say same side, we could say they both need to be on the right side, or they both need to be on the top, or they both need to be on the bottom, but like you can't have them diagonal from each other. That would just be wrong. All right, example 4, last example. A bag has blue and silver marbles at a 7 to 3 ratio. If the bag has a total of 60 marbles, how many of them are silver? Oh my goodness, again, one of those dreaded ratio to all, ratio of all questions. So 7 to 3, 7 would be blue, and 3 would be silver. And a 60 is the total. So so if the ratio of marbles is 7 to 3, and we need a ratio total, 7 plus 3 is 10, so the ratio total is 10. So, in order to figure out how many of them are silver, I need the silver number, and I need this number right here, the ratio total. So one way of setting it up is there are 3 silver marbles, and there are 10 total. That's a ratio total. If there are 60 total, that'll go on the bottom. Then, how many of them are silver? We can do it, let's flip the numbers. Let's put 10 total and 3 silver, which would mean the 60 total goes on top in this case, and the unknown, how many silvers, go on bottom. Let's do the ratios left to right. So we can do 3 silver first and 10 total, which means the 60 total goes down here across from the 10, and the unknown goes right here. Or we can do it sideways as well, except reverse, go 10 total. Or, actually, I guess I already did that. Let's do 10 total up there, and then did I do the 3 silver on the bottom yet? No, I did not. Yes, I did. I did on the first one. I can do the 3 silver on the right. So 3 silver marbles, 60 total, and how many silver? So yeah, all 4 of these will get you the right answer. And why? How do you know? Well, if you look at this one, 10 total, 60 total, that goes together. Goes together right there. 10 total, 60 total, 10 total, 60 total. They're either going to be right next to each other, the same category next to each other, or on top of each other. You're never going to see them diagonal from each other, like, oh, 10 total is up here, and then the 60 total is down there. Like what Helen has, that's just wrong. 8 all in one corner and the 32 all in the other corner. Totally wrong. So you set it up this way. If you set it up in any of these ways, you will get the correct answer once you try to solve for x. So anyways, go ahead and try some more proportions on your own, especially now that you know how to set them up in different ways. You don't have to set them up in different ways, but set it up in the way that you think works best for you. Go ahead and try some more on your own. Good luck.